Hello, everyone. My name is Steven,
And I'm Snape.
and our project is Lila. So if you recall from our last presentation, we had an idea to make a multi-purpose AI helper, but we quickly realized that it was very difficult given our time constraints. So we just decided to overhaul the project idea. So now we're making a communication device to help deaf people and hearing people communicate with each other, specifically hearing people who do not know sign language. So how this will work is if the deaf person wants to communicate, um, he or she will assign the letters and numbers to the device's camera as if they're spelling out what they want to say. And the device will essentially interpret this stream of characters as a grammatically correct sentence. We'll get into how that works. And then it will play that sentence as an audio file through the speaker. And when the hearing person wants to communicate, he or she will just speak into the device's microphone, and then the device will interpret what the person is trying to say, convert it to text, and display it on the LCD screen. And our goal is to make it like a sort of handheld device that can be attached to a lanyard worn by the deaf person.
So where do we stand with our project? We've essentially confirmed that all our code for the microphone, the speaker, the camera, and the LCD screen works independently. And we've tested it on the ESP32. Um, However, we need to now start testing on the ESP32, like ESP32S3 and then the ESP32 Pico V302. Um, we've now decided to use two ESP32s, or two microcontrollers, and I'll get into that more on the next slide. But currently, we're facing issues with flashing the Pico board and testing it. Um, so once we resolve this issue and confirm that all our code works and all our hardware works with the given pins, we'll try to make a PCB schematic and board, ideally by Monday. If we can meet this deadline, we'd consider ourselves on track, because we can then probably get two iterations of testing on a PCB in before the final project deadline. And that would be ideal for our group. So some of the design choices that we've changed is we're now using two ESP32s or two microcontrollers because we have four devices that communicate using I2C or I2S, and each MCU only has two I2C peripherals. So we're using the ESP32S3 and the ESP32 Pico V302. The Pico V302 is essentially just an ESP32, but it's just the core, so without the Wi-Fi antenna, because we realized that only one of our ESP32s needs the Wi-Fi antenna, and we can be more power efficient if we use the other one, which doesn't have a Wi-Fi antenna. We've also decided to use a camera to detect the sign, letters, and alphabets that the deaf person makes. We're also using an LCD screen to display the words spoken by the hearing person, so the non-deaf speaker. And then we're using a tornado server setup to process audio data that we collect from the microphone when the hearing person speaks. And we're also using one to communicate with the ESP32 to send an audio file that we played back on the speaker when the deaf person signs, so the hearing person can understand them. And in terms of our software design choices, we're using two APIs or three APIs. We're using the OpenAI ChatGPT API because we're using letters and numbers. We're using the API to feed it in the letters and numbers to construct it into a stream of characters, construct the stream of characters into a grammatically correct sentence. Because we realized that our model, if it inaccurately classifies a letter or a number, the OpenAI API is smart enough to be able to account for this misclassification and then make it into a correct word. We're also using the 11 Labs API to convert text to speech. So once the ChatGPT API converts the stream of letters into a sentence, we'll feed it into the 11 Labs API to convert it into an audio file that we can play back to our speakers so the hearing person can hear it. And then we're using Assembly AI API to convert the raw audio data that the hearing person, when they speak into the microphone that we get, and then we generate a WAV file from it to convert that into text that we can then show on our LCD screen.
Yeah, so we learned a few things. First, we learned how to create AWS EC2 instance by following Leah's guide. We also learned how to use APIs, got pretty familiar with that. We originally thought it would be rather difficult, but seemed like a pretty uh set in stone process for most APIs. Um, we also learned how to use Edge Impulse, which is the user interface we're using to create and run and train our models and upload or create the library for our model. Um, and we will try to use that more to improve our model accuracy in the future. We also learned more about sign language, mainly that it involves a lot of movement, and since motion detection is pretty complex, we just decided to use letters instead, letters and numbers, because they're static, given the scope of our project. We also learned the basics of RTOS, which we plan on integrating into our device to manage all of the different capabilities that the device has. So we had a couple interviews after our initial presentation. One person said, originally, we did not have the idea for an LCD screen and the microphone. So one person said that we needed a way for the hearing person to communicate back to the deaf person. So came up with the LCD screen to display text that the person says and using the Assembly AI API to convert audio to text. Another person said it should be as easy as possible for communication to occur, because if it wasn't, then the person might as well just take out their phone and just like type what they want to say on their phone instead. So we decided to make the device attachable to a lanyard in hopes that that would make communication much easier. Extendable lanyard, so the person can like extend it to the other person, the hearing person, when the hearing person wants to talk, and then bring it back when they want to start signing. Yeah, so we have a couple questions as well. Currently, our biggest weakness, but also this is rather a modular task, is our model, which is achieving really bad accuracy. Our training data set is still rather small, so that's what we think our main issue is coming from. But we were wondering if any of you are experts on deep learning and have any suggestions for improving the model. For context, we're using FOMO, which is object recognition, using bounding boxes, and we're using the MobileNet model architecture. Also, our other question is, do you think design-wise, if we should have our camera recognize the back of the person signing or the front? Because if it recognizes the back of the hand, then the lanyard can just sit on the deaf person's chest, and then they can just sign in front of them, and the camera can just recognize the back of the person's hand and recognize those letters. And it'll just be easier for the person because they don't need to like hold the device in a certain way. But on the flip side, if it recognizes the front of the hand, that means we would either need to have the deaf person sign towards them, which is going to be take a little bit of time for them to get used to, or we would need to bring the device out in front of them and then face the camera to the person and then sign in that manner. So yeah, what do you guys think about that?
The problem with signing like with the back is like some like signs are like very hard to distinguish if you're looking at them from the back, because sign language, ASL at least, is a front-facing language. So that's like another reason like our accuracy might really reduce.
Yeah, so for example, this is a T, this is an N, this is an M, this is a S. Sorry. Yeah. Yeah. Yeah, so there's a lot of, they all look relatively the same. So model accuracy could decrease from having it recognize the back of the hand instead. And then lastly, we mentioned earlier that we had some error with the ESP32 Pico. We were getting some port dump flash config error, also getting a brownout error. We were wondering if you guys had any thoughts on solving this. And yeah, I think that's our entire presentation. So
Thank you.
thank you.